Hello students, welcome back to my YouTube channel. In this video, I am going to discuss about force between two long parallel current carrying conductor for NEET and JEE. If two current carrying conductors are placed some distance apart, there will be a force between them. If the current are going in the same direction, like this, the force is attract. That means these two current carrying conductors attract towards. Okay. If the current is going in the opposite direction, the force is repelled. That means these two repel with each other. Okay. Why this force is acting on it? You see this is a one current carrying conductor. This is another current carrying conductor. There will be a force between them because this current carrying conductor produces a magnetic field and this will also produce a magnetic field. So there will be an interaction between these two magnetic fields so that there is a force experience. Okay. You may be noticed that in the electric lines are placed some distance apart. That is due to avoid this force. Okay. Now we will see how much is the force. And consider this is the first conductor and this is the second conductor. The current is I1 through this and current is through this conductor is I2. Okay. And consider these two are placed d distance apart. Okay. Then the force between them, that means this first conductor attract the second conductor. The first conductor attract the second conductor toward this. Here the force is acting on the second conductor. So F2, 1. Who is exerting? 1 is exerting. So this is the F2. Okay. What about the magnitude? F21 is equal to mu 0 I1 I2 divided by 2 pi d into L. What is L? L is the length of this conductor. Okay, this is the thing. Okay, then the same magnitude, the second conductor attract the first conductor like this direction. So the second conductor exert a force on the first conductor. So F12 is in this direction and the magnitude is similar to this, that is mu 0 I1 I2 divided by 2 pi d into L. L is the length. In the L length portion of this first conductor. Okay. Then if the current are in opposite direction, that is I1 and I2 are in this direction. I1 is in this direction, I2 is downwards. This I consider the first conductor, this I consider the second conductor. Okay. And the distance between them is d. Okay. So now you see this first conductor repel the second conductor like this. The force acting on the second conductor, who is exerting? The first conductor. So F21. So F21 is mu 0 I1 I2 divided by 2 pi d into L. What is the L? In the L length portion. This is the L length portion of the second conductor. Okay. The similar way, this second conductor repel the first conductor in this direction. That is the force acting on the first conductor by the second conductor. This direction. Okay. The magnitude is similar to this, that is F12 is equal to how much? Mu 0 I1 I2 divided by 2 pi d into L. L is the L length portion of the first conductor. Okay. This is about the theory. Now we will go to the type 1 problem. Okay. So look at here, two current carrying conductors carries a current I1 and I2 are placed d distance apart. Okay. Now the current in one of them is increased 2 times and its direction is reversed and the distance between them is 3 times. What about the force? Okay. Now you see. So initially this is the case. Okay, these two current carrying conductors placed this distance apart. So here you see that the current are going in the same direction. So the force is an attractive. So the force is mu 0 I1 I2 divided by 2 pi d. Mu 0 I1 I2 divided by 2 pi d into L. Okay, that is the L length portion of the conductor. Okay, if we will consider the second conductor, the force acting on the second conductor, L length portion of the second conductor. Okay, clear. Now what they told? The current in the one of the conductor is reversed. Okay, so that means you see this. This is the one conductor, this is another. I1 is in this direction, I am reversed this I2. Okay, this initially what value? That is 2 times, that is 2I2, and the distance between them is 3 times increase, 3d. What about the force? Initially you can see that the force between them is attractive because they are acting in the current is going in the same direction. But now you see this, these two are going in the opposite direction. So the forces are repulsive. What about the magnitude of the force? Here this is attractive. Attractive force. Then you will see the repulsive. Okay. So what about the force? You see here F is equal to mu 0 I1 into I2. Initially I2 are in this direction, we have taken as positive. So now it is in opposite direction. So 2I2 divided by 2 pi into the distance between them is 3d into L length portion. Okay. From this I can take this minus 2 by 3 outside, then mu 0 I1. This is F dash like that I am taking. Okay, I1 I2 by 2 pi d. Okay, what about this value? This is equal to the old F. So this F dash is a value is 2 by 3 F. Why this minus sign? This minus sign because the force is repulsive. Okay, the force is repulsive. This is the magnitude. The magnitude of the new force is increased by 2 by 3 times. Okay, then this is about the type 1. Two long current carrying thin wire both with a current I are held by insulating thread of length L and are in equilibrium shown in figure. This is the two current carrying conductors are placed like this way. If the wire have mass lambda per unit length, then the value of I is, we need to find out the I current through this. Okay, you look at here is a one current carrying conductor, this is another current carrying conductor, these two are held like this. Okay, so we need to find out the current. Okay, we can draw the diagram. This is the insulating thread and this is the one current carrying conductor, this is another. Okay, the current, the magnitude is same. Okay, here also I and this also I. Okay, what about this angle? This angle is theta, this length is L. Okay, then now we will see what are the force acting on this. You look at here, there is a tension is acting, so this is now equivalent. Okay, the tension is acting in this direction. Okay, and there is a downward gravitational force is acting, that is mg. What is m? M is the mass of the current carrying conductor. They are given as lambda is the mass per unit length. So I consider the L length. L is the length of the conductor. If L is the length of the conductor, what about M? M is equal to mass per unit length into L. So I can replace this by lambda into small letter. Okay, then They are given that these two current carrying conductors are at equilibrium. So there is a force of repulsion is acting between these two current carrying conductors. That means through this one current is going like this, and another current carrying conductor, the current is going in this direction. Okay, so there is a repulsive force because two current carrying conductors are placed some distance apart. If the current is in the opposite direction, they will repel with each other. So the repulsion between them is along the line. This is the force is acting. What about the force value? Force F is equal to mu 0, the current through the first I into current through the second, that is also I, mu 0 I1 I2 divided by 2 pi into the distance between them. So I am taking this is O, this is P, this is Q, and this point is R. So what is the distance? That is PR into the length. Length is, we are already taken as the length is L. Okay. Then now we need to find out the PR. Okay. To find out the PR, please take the triangle OQR. OQR. From the triangle OQR, what about the sine theta? Sine theta is equal to QR divided by the hypotenuse. What is hypotenuse? That is OR. That is the length L. So QR is how much? That is L sine theta. Okay. Then what about the PQ? Sorry, PR. PR is 2 times. So this is how much? That is the 2 times of that. Okay. So QR is equal to L sine theta. Now we can write F is equal to how much you will get? That is mu 0 I square divided by 2 pi into 2L sine theta. Okay, sorry, that is to be, okay, it is correct. Now we have to put here the small letter L. Okay, then this is theta. Then I am going to resolve this tension into 2 components. Okay, if this is theta, this is also theta, because this is one parallel line, this is another parallel line. Okay, so now we will see this tension. If I will resolve it, okay, one is along the horizontal like this, I will get one component. Okay, and another component along this direction I will get. Okay, this is what component? That is T cos theta, and this is T sin theta. Okay, if these two current carrying conductors are at equilibrium, the net force is 0. That means T cos theta is equal to lambda Lg, you have to get. Okay, and T sin theta is equal to F value. That is F is equal to mu 0 I square divided by 4 pi L sin theta into small letter. This is equation number 1 and this is equation number 2. Now I am going to take 2 by 1. Okay, what is 2 by 1? That is T sin theta divided by T cos theta is equal to mu 0 I square divided by 4 pi L sin theta into small letter L divided by lambda into small letter G. Lambda into L in the small letter. This is L and L is cancelled. Then what is remaining? Okay. Then now you will get this mu 0 I square, and this T and T cancel. Here you will get as sin theta, you will get here cos theta. Okay. Mu 0 I square. This 4 pi and this will come to downside. So 4 pi L sin theta lambda G you will get. Okay. Now I am taking this to this side and this to this side. Now so that we will get I square. So I square is equal to 4 pi L, that is a capital L, sin square theta lambda G divided by mu 0 cos theta. Mu 0 cos theta. Okay, from this you can find out the I value, take the square root. Okay, if you take the square root of this, 4 square root is 2, that is 2, and the sine square root is sine theta. So 2 sine theta square root remaining, how much is that? That is pi L, that is pi L, and lambda is a G is divided by mu 0 cos theta. Okay, this is the current through the current carrying conductor. Okay, this is about the type 2. Now we will see type 3. Okay. Type 3, if a current flows through a spring, the spring will compress or expand, or there is no change happen. What will be happen to the spring, we have to see. Okay, so what is the question? If the current flows through a spring, what will be happen to the spring? Okay, what is a spring? Spring we can consider as number of closely spaced circular turns. Okay, so this I am considered as the back side, this dotted one. Okay, clear? Okay. Each circular turn, what about the current direction? Look at here, this and this. These two circular turns, we look at the current through the each circular turn is similar. Okay, now you see this. Now you see I am taking two neighboring circular turns. This is one circular turn and this is another. Okay, clear? Okay. Look at here. In this, the current is going in this direction. Here it is this direction. Okay, this is the current direction. Now you see these two are closer each other. So the current is going in the same direction. There will be an attractive force between these two. Okay, and this you see in the back portion. Here the current is also in the same direction. So these two back portion will attract with each other with a force. Okay, so likewise each neighboring circular turns attract with each other. So the spring compress. When the current flows through a spring, its shape is to be changes. That is, it will be compressed. Okay, spring compress. Okay, spring compress. This is about the type 3. Now we will see type 4. Type 4. Okay, so two current carrying conductor. Okay, like this. The current through each one is 1 ampere. Current through this also 1 ampere. And the distance between them is 1 meter. What is the force of attraction between them? This is the current are in the same direction. Then what is the force of attraction between them? Okay, so if two current carrying conductors are placed some distance apart, the force formula is mu 0 I1 I2 divided by 2 pi d. Okay, so now you can substitute the I1 I2 value, that is 1 into 1 divided by 2 pi into 1. Okay, what about the mu 0 value? That is 4 pi into 10 power minus 7 divided by 2 pi. So you will get the answer is 2 into 10 power minus 7 Newton. Okay, this is the force between two current carrying conductor are placed 1 meter apart and the current is 1 ampere flows through the current carrying conductor. This is about the type 4. Okay, now we will see type 5. Type 5. If two current carrying conductor, okay, this is the two current carrying conductor carries a current I1 and I2 are placed d distance apart. draw a graph shows the variation of force and product of the current. That means we have to draw a graph versus the force versus current graph. Okay, then so what about the force between the current carrying conductor? That is mu 0 I1 I2 divided by 2 pi d. Okay, clear? So if I1 and I2 are in the same direction, what about I1 into I2? The I1 into I2 is I1 into I2 is positive, and the force also will get us positive. Okay, then now you see. So from this we can get the force is directly proportional to I1 into I2 graph. Okay, I1 into I2. So now I am going to take in the y-axis force and the x-axis I1 into I2. Okay, then okay, clear? So initially I am taken I1 and I2 are in the same direction. If I1 and I2 are in the same direction, what about the product? The product is positive, so in this direction. And what about the force? Force is an attractive force. Okay, the force between them is an attractive, so that I am considered as a positive. Okay, so the graph is like this. Okay, the graph is to be like this. This is what force? The attractive force between the current are going in the same direction. Next, if I1 and I2 are in the opposite direction, force is attractive. Okay, if I1 and I2 are in the opposite direction, that means if the I1 is going in this direction and I2 is in this direction, opposite direction, so this downward one I am taken as negative. Okay, so I1 into I2 product is negative, so that will come to like this. This is minus I1 into I2, and the force is also, we will get it as negative. Force is also negative, so this is the minus x-axis. Okay, and is directly proportional, so we can take like this. Okay, this is the graph for if the current is going in the opposite direction, the force between them is the repulsive force. That is, this is a variation of the force versus the product of current through the current carrying conductor.
Thank you for watching the video. Please subscribe my channel. If you like this video, please put like and share.